Hello, PascoMath grade 8 teachers. Today we're going to look at standard 8.EE.1.1. We're going to look at unpacking the standard a little bit, what the teacher should be doing in the classroom as well as what the students should be doing, and anticipating some misconceptions students might have with this standard, and then what you can do to address those misconceptions. So let's get started. So the standard says, know and apply the properties of integer exponents to generate equivalent numerical expressions. So if we unpack that, there's a lot to that simple sentence. Students build on their earlier experiences with adding and subtracting integers by computing with integer exponents. Students should know and be able to apply the following properties listed below of integer exponents for all non-zero real numbers a and b and integers n and n. So focusing on what the teacher should do. First, use a conceptual approach to have students discover the laws of integer exponents. And they need to provide examples of the processes that lead to the rules of each law. And what we mean by provide examples would be to set up the conditions for students to discover some of the rules. So if we're talking about products of powers that have the same base, we could just do something as simple as 4 to the second. And we can say, well, multiply that by, let's go 4 to the third. And if we expand it out, 4 to the second, well, that means 4 times 4. And 4 to the third means 4 times 4 times 4. And then ask, well, how many times is 4 being used as a factor? And students would say 5 times. And so 4 to the second times 4 to the third is 4 to the fifth. We can try a different base. We can just say 3 to the third times 3 to the fourth. Have students expand it out. Well, that's 3 times 3 times 3, 3 to the third. 3 to the fourth is 3 times 3 times 3 times 3. 3 uses a factor 4 times. And 3 is used as a factor altogether 7 times. So 3 to the third times 3 to the fourth is 3 to the seventh. You can do many more examples that build up to this, and then give an example of something like 7 to the 10th times 7 to the 15th. Most students, unless they want to be punished, would not want to expand that out. And so they're like, all right, let's skip that step. I don't want to do all that. Is there a shortcut? Is there a pattern going on here? And students will realize pretty quickly if you're given enough opportunities before to look at 7 to the 10th times 7 to the 15th, and they'll say, well, that's 7 to the 25th. They'll jump to the rule. And that's really math practice, opportunity for math practice 8. Look for structure, repeated reasoning, patterning definitely is occurring there. Some other properties that they could practice on, again, the same reasoning, the same logic, I would probably set up in a table, could occur for if you're raising a power to a power. Also, trying to allow students to make sense of zero and negative exponents. I think that is something that they have difficulty conceptualizing. And so, again, I would rely on some patterning. And so I would say maybe set up a nice table for them and have them expand out to discover and say like, well, 3 to the fourth is equal to what? And so 3 is used as a factor 4 times, so 3 times 3 times 3 times 3, 81. 3 to the third, well, that's 3 times 3 times 3, well, that's just 27. 3 to the second, 3 times 3, that's 9. 3 to the first, well, that's just 3 used as a factor once, so that's just 3. And then we get to this key point here, 3 to the 0 power. And many students will say 0, and some will say 1. And I get excited when students have 2 different answers out there because then we have a debate. We have a lot of conversation about, well, what's really going on here mathematically? And allow students to grapple with it, and they'll see that there's a pattern going on here. We are using 3 as a factor 1 less time, so if we divide by 3, we can get from 81 to 27. We can get from 27 to 9. If we divide by 3, we can get 9 to 3. So then if the pattern continues, if we divide by 3, 3 divided by 3 is 1. So to keep the pattern consistent, to keep the mathematics here legit, we know that anything to the 0 power, because this would work with whatever base you use, and have them discover that too. Like you can use the fourths, fifths, other things there. And so now we have established this key point here, that anything to the 0 power is equal to 1. So again, we just didn't tell them that. We had them discover it. And then we can also use this table to explore negative exponents. And so it's like, all right, well, we already addressed anything to the 0 power is 1. So let's start talking about negative exponents. And so we got 3 to the negative 1. And again, we're going to get two answers out there. Some students will say it is equal to negative 3. And others will say, no, well, if the pattern continues, it's going to be equal to 1/3. And so again, we have some conversation about, well, what's happening here? And if we're dividing by 3 as we go down the table, I know 1 divided by 3, so 1 divided by 3 can be represented as 1/3. So we know that is mathematically correct. And then as we continue to go down the table, 3 to the negative second, we can talk about that. And then again, some students might say negative 9. Those that see the pattern will be 1/3 divided by 3, which is 1/9. And now all of a sudden we start making connections at different points in the table. So this 3 to the negative second and this 3 to the second, we can start making some connections there. The more connections we can make, the better for the students to understand to depth what's going on with negative exponents. So let's look at what the students should be doing. And again, the teacher should set up the conditions for students to discover the properties, and the students are the ones that need to discover those by making sense of the examples. One we didn't talk about was discovering a property such as, let's go 3 times 7 to the 4th. And so we want to make sense of this. And so again, anytime there's a power, and we're trying to get to the rules, we want students to expand it out. And so, well, that's equal to 3 times 7, 3 times 7, 3 times 7, 3 times 7. So 3 times 7 is used as a factor 4 times, and so honoring what the 4th to the 4th power means. And then we can use some properties here to rearrange. And so if we rearrange, we can do 3 times 3 times 3 times 3 times 7 times 7 times 7 times 7. Which, if we wrote those as powers, well, that's 3 to the 4th times 7 to the 4th. And after working a couple examples, we want them to make a connection between this and that. Again, we can say we want to be efficient. We don't want to have to do all this messy stuff in the middle. What if this was the 20th power? Would you want to expand that out 20 times? And so we're looking for a shortcut. We're really emphasizing math practice 8 here, expressing that patterns in the repeated reasoning here. And so again, we want students to generalize that. If we were just using, let's say, a generalized format of a times b to the n, well, that's just equal to a to the n times b to the n. And again, that comes from the students, not the teacher. We also want students to generate equivalent expressions in simplest form for products and quotients of numbers, with integer exponents having the same bases. So when thinking about some misconceptions, students will often confuse the rules. And this will be magnified if you just give them the rules to memorize without building the conceptual understanding first. It'll be very evident that they don't understand why the different rules work. And to address this misconception, I can't emphasize enough that students need to discover the rules. Students are also encouraged to write their reasoning so they can clarify the explanations for themselves. Another piece that I just want to touch on here, I didn't have it on the slide, but it's just an opportunity, I was just thinking of it, is when we're talking about the division of powers, that rule. And so let's say that I have 3 to the 5th divided by 3 to the 2nd. And one misconception that we see show up later, not in grade 8, but is if we actually expand this out, we have 3 times 3 times 3 times 3. So 3 is used as a factor 5 times. In our denominator, we have 3 used as a factor twice. And so I see sometimes or hear sometimes of students saying that these just cancel. They actually use the word cancel. And I'll just caution against that because they're actually we need to call it what it is. And so anything divided by itself, if we rewrote this, is equal to 1. And so these are really just a different version of 1. 3 divided by 3, 3 divided by 3, and those are 1. And so after that occurs, we're left with 3 used as a factor 3 times, so 3 to the third. And so again, I just really emphasize the language there. Just be careful you don't fall into the trap of saying they just cancel. Students just think they magically disappear. We need to get back to the math of why those 3's are no longer represented and what they actually became. So I just like to emphasize that. That's it for 8.EE.1.1. I appreciate you listening. If you have any questions, feel free to contact me or your regional specialist. And thank you for making PascoMath more awesome.